Hello folks, and welcome to Solving Equations Review. We will be solving some x squared equations, and then we will be getting answers that will be totally radical. Alright, you need your pen and a pencil, your notes to take notes, and a calculator. You do need to write down all 4 examples and the last slide with things to remember. So we will get started. Example number 1 says 5x squared minus 4 equals 96. Well, let's take a minute and discuss how, on a sidebar, discuss how we would solve 5x minus 4 equals 96. Notice that this is to a power of 1 and this is to a power of 2. But if you notice, we will be doing the same sort of steps for each one of these problems. So over here, if I had 5x minus 4 equals 96, I'm pretty sure that most of you would tell me, well, add 4, Mrs. Brendan, to both sides. So if I do that, I get 5x equals 100. And then what would I do to get x alone? I would divide by 5 on both sides, and I would get x equals 20. Now, if I take this problem and do this problem, I'm going to be doing the same steps. But this time, I don't want to get x alone. I want to get x squared alone. So we're always trying to isolate our x squared. So if I added 4 over in this problem, guess what I'm going to do over here? I'm going to add 4 to both sides. I get 5x squared equals 100. Then I'm going to divide by 5, just like I did over here in my sidebar. Okay, I divided by 5, and I get x squared equals 20. Now, the difference between this problem and this problem is that this is an x to the power of 1, and this is an x squared. And an x squared, if you remember from Algebra 1, is that if you have a power of 2, you should have 2 solutions. So what is the inverse of squaring? Yep, you got it. Exactly what we've been doing. Square rooting. And so a square root and a square cancel each other, just like a 5 divided by 5 cancels, or a minus 4 and a positive 4 cancel. And so we get x equals plus or minus the square root of 20. The reason why we get a plus or minus is because we should have 2 solutions, because it's an x squared. Over here, 1 solution. Over here, 2 solutions. All right. Now that we've got x equals plus or minus the square root of 20, we should be doing what we've been doing in class, which is simplifying our radicals. So how do I get the square root of 20 broken down? Yep, you got it. That'd be the square root of 4 times the square root of 5. The square root of 4 is 2. The square root of 5 is the square root of 5. And we still have the plus or minus out in front. So x equals plus or minus 2 square roots of 5. So notice, I'm simplifying my radical, and I did get a radical answer. All right, let's do problem number 2. Negative 2x squared minus 6 equals negative 90. Again, I'm trying to get the x squared alone. So I'm going to do just like I would if I were solving a linear equation. I would add 6 to both sides first. I would get negative 2x squared equals negative 84. Divide by negative 2 on both sides so that my negative 2 cancels. I get x squared equals a positive 42. I square root both sides so that my square and my square root cancel. And I get x equals plus or minus the square root of 42. Now, can I break down the square root of 42 by dividing it by a perfect square? Well, 4 doesn't work. 16 doesn't work. 9 doesn't work. 25 doesn't work. So 42 cannot be broken down, so we will leave our answer in radical form. That is the simplest radical form. So sometimes you can break down your number, your radicand, and sometimes you can't. But remember, we still have a plus or minus because we should have two solutions. All right, let's try another one. Excuse me. 5x squared plus 33 equals 3. We're trying to get x squared alone. We subtract 33 from both sides. We get 5x squared equals negative 30. Divide by 5 on both sides. We get x squared equals negative 6. Square root to get rid of the square and the square root cancel each other. X equals plus or minus the square root of negative 6. But if I put that in my calculator, I will get a domain error, or no real solution. So we can never have a radical that has a radicand that's negative. So no negatives allowed, therefore the answer is no solution. Okay, let's try example number 4. Again, I want to get this x squared alone, but before I do that, I want to get all of that alone. So I'm going to subtract 6 from both sides first. I get 3x squared equals 6. Oops, divided by 14 equals 6. Now, to get the 3x squared alone, the opposite of dividing is multiplying. So I'm going to multiply both sides by 14. And I'm going to get 3x squared equals 6 times 14, I believe is 84. And then I'm going to divide by 3. And 84 divided by 3 is 28. So x squared equals 28. Square root both sides, so that my squared and my square root cancel. I get x equals plus or minus the square root of 28. And now I can see if I can break down the square root of 28. The square root of 28 breaks down into the square root of 4 and the square root of 7. The square root of 4 is 2. The square root of 7 stays. And then I bring my plus or minus down. And my answer is x equals plus or minus 2 square roots of 7. Now notice, all of my answers were radicals except if I had a negative underneath the radical, and then it's a no solution. So things you need to remember, so please write this down. 1, we're always trying to isolate the x squared. That's our goal. Once we get it isolated, in order to get rid of the squared, we take the inverse, which is square rooting. Okay, that's the inverse. We always simplify our radicals because we're not going to have any decimal answers. Okay, so that's where you need to know your perfect squares. There's no negatives underneath the radical. So if there is a radical that has a negative number, we say that's a no solution. And always remember the plus or minus because x squareds always have 2 solutions. Okay, so that is all for today. Thanks for taking good notes, and we will see you tomorrow.